Hi, I'm John. Welcome to the next video in our Haas certification series. Today, we're going to teach you how to unload and load parts in a CNC milling machine. Here's what we'll cover: the basic parts of mill vise and fixtures, cleaning the fixture before loading the part, locating the part in the fixture and checking your work, what to do after you press cycle start, and cleaning and removing the part in preparation for the next run. Ready? Let's go. It's very important for you to get in front of an actual CNC machine tool to get hands-on experience and begin building familiarity with how the machines work. Contacting your local Haas factory outlet, or HFO for short, is a good place to start. Technical schools and junior colleges in your area are also a good place to gain access to CNC milling machines. Remember, this certification series will present a basic understanding for what a CNC machine is and how they work. But nothing can replace spending hands-on time using a machine to really prepare you for this line of work. So this lesson is where the rubber meets the road. Up to this point, we've been familiarizing you with the machines and machining processes, safety features, and so on. Now it's time to show you what you're actually going to do as far as metal cutting goes. You can't just set a workpiece on the mill table and cut it. It'll go flying through the air as soon as the cutter makes contact. Workpieces, whether they're raw stock or nearly finished workpieces, are still placed in fixtures which attach to the mill table. The most common type of fixture is a mill vise. A mill vise is clamped to the mill table. The vise has a stationary section and a movable section. Each section has a jaw attached to it, and the jaws are what actually contact the part. The movable section of the vise is attached to a screw, and as we turn the screw with the vise handle, the vise opens and closes. So look at this mill vise setup. I have what's called a stop attached here. Remember, the basic milling machine has 3 axes, X, Y, and Z. In order to precisely machine each part, it must be located in the same place along each of those axes every single time I load the part. So, the part stop here locates the part in the X-axis. The stationary section of the vise locates the part in the Y-axis, and the bottom of the vise locates the part in the Z-axis. Now, the vise jaws can have a number of different configurations. There's a straight hard jaw for clamping a part that sits all the way down in the vise. We call these hard jaws because they're made of hardened steel and will provide an accurate locating surface that won't wear out or be damaged. When I'm using hard jaws, but I need the part to sit up higher in the vise, I can also place parallels under the part so a specific amount sits above the vise jaws for cutting. Jaws can also be made of a softer material and cut to a specific shape. For example, a common shape is a step jaw with this little notch cut in them. The part will sit down on this edge and be gripped here. Obviously, the amount of contact area a jaw has with the workpiece will increase the grip or clamp force on the part. So far, these jaw examples have been designed for clamping on rectangular workpieces that are typical of raw stock shapes. But how do I hold a part on the second operation when it's cut to an irregular shape? When we say second operation, this usually means we've already done some machining on one side or one section of a workpiece, and now we need to reclamp it in a different position to machine other features. For this, we make nested jaws. We actually cut the irregular shape in the jaws to give us a unique clamping method. This type of jaw usually doesn't need a stop like the other setup because the shape of the profile will force the part to locate in the same place in the X and Y axes as the vise is tightened. There's another type of vise called a dual station vise. This has a stationary center section and 2 movable jaws on either end of the vise. When we rotate the screw, it opens and closes both jaws. We can hold two of the same part, so we can cut an operation on two parts in one cycle, or we can hold the first operation in one station and the second operation in another station. When the cycle finishes, we get a completed part with one part finished on the first operation. Okay, that covers mill vices, but many shops use specialized fixtures to hold specific parts. These fixtures can be very complicated or very simple. It all depends on the shape and the material of the workpiece. Here at Haas Automation, we use a wide variety of fixtures, but the two main types are tombstone fixtures and window fixtures like these. Now, there are countless types of fixtures, but they all have two things in common. Number one, they all have a method for locating the part that is repeatable, and number two, they all have a way to clamp the part tightly for the machining operation. Whether you're using a vise or a specialized fixture, you're going to have to perform several functions when loading and unloading parts. Your supervisor will train you on exactly how to load and unload parts in the machine, and that process will likely vary from setup to setup, but generally the process will follow these steps. Step 1. After the machine is finished cutting the part, you want to clean the workpiece of chips and coolant. Normally, this is done with the air gun. You always want to start at the highest point on your part or fixture and blow the air with a sweeping motion side to side like this. The idea is to prevent chips and coolant that are on the part from falling into the vise or the fixture when you remove the part. You especially want to be sure to blow off your specialized fixture. There may be socket head cap screws or other clamping devices that collect chips and coolant in the hex head on the screw. You must clean these well, or your hex wrench is not going to seat properly and may strip when you try to loosen the screw. Be careful if the part has pockets or blind holes where coolant can pool. When you go to blow these areas, you may end up getting soaked. I always recommend hiding behind the door with just your arm and the air gun inside the machine on this initial cleaning procedure. You can even avoid blowing air at these particular features until you've unclamped the part and then can lift it out and dump the coolant. The second step is to loosen the vise or fixture and remove the workpiece. You may want to blow chips and coolant off of the part while you're holding it in your hand. Flip it around and blow it off from all sides. Set the part down in the location where you'll be measuring features or dimensions, and then get ready to load another part. Step 3 in this process is to thoroughly clean the vise and fixture. It's super important that you make sure that no chips or debris are on any locating surface of your fixture. Remember, cleanliness is next to godliness, and the machining gods will smile on you if you keep your fixtures clean. Always look at these surfaces and visually verify that they're clean and free of debris. Keep an eye out for dings or dents on the locating surfaces too. If you do clamp a part with a piece of debris between the part and the locating surface, it can put a dent or a ding in that surface that can mar each part you put into the fixture. If a piece of debris is large enough, it can even cause the workpiece to be cocked or out of position in the vise, which will mean that all the machining we do on that part will be slightly out of place. Remember, we're making precision components on this machine, and the slightest piece of debris between the part and the fixture can cause it to be out of tolerance or scrap because of a bad surface finish. Okay, step 4 is to load another piece of stock. Start by setting the part down on its Z-axis locating surface. Now, push the workpiece against the locating surface in the X and Y directions at the same time. While still holding it against the locating surfaces with light pressure, lightly tighten the vise or fixture clamps. Pay special attention to see or feel if the part has moved away from the locating surface when you snugged the clamping pressure. At this point, your process will vary depending on the setup and workpiece. If the part has very thin walls, you may be tightening it with light pressure or even using a torque wrench. so that the workpiece doesn't bend or deform from too much jaw force. You might be tapping the top of the part to make sure that it's sitting down in the vise or fixture before applying the final clamping pressure. Your supervisor will instruct you on the proper method for this particular setup. Step 5 is to visually look at the locating surfaces and verify the part is in the correct position. Your supervisor may even have you using a thin piece of shim stock to determine if there's a gap between the part and the locating surface. When you're sure, I mean 100% sure, that your part is located properly and the work holding is clamped with the right amount of pressure, it's time to close the doors and press cycle start. This 6th step does not end with pressing the button. A common mistake among operators is to press cycle start and turn your back on the machine. This is a terrible habit to get into, and one day it'll come back to haunt you. I recommend operating the machine like this, with one thumb on the cycle start button and the other thumb on the feed hold button. This position works well when you're starting a new run of parts or starting the first part of the day. You need to be ready and quick with cycle start and feed hold. Keep your thumb on that feed hold button and anticipate that something is going to go wrong, so you're ready to react if it does. Once the first cutter in your program enters the workpiece and sounds like it's cutting fine, then you can remove your hands from the buttons. I never recommend turning your back on the machine, especially for the first 5 or 10 parts you run each day and after a new setup on the machine. And so the process starts all over again. Remember to clear chips that build up on the table and way covers periodically throughout the day. And I repeat, it's very important for you to get in front of an actual CNC machine tool to get hands-on experience and begin building familiarity with how the machines work. All the online instruction, videos, and test taking in the world can't take the place of actually using the machine and understanding how they work firsthand. Contacting your HFO is a good place to start for information on where to get time in front of a machine. So, let's do a quick recap of what we learned. For safety, hide behind the door when blowing off your part and fixture. Make sure there are no chips or debris on any locating surfaces of your fixture when placing a new part in the fixture. Set the part down in the fixture and then push against the stops in the X and Y axes. Tighten parts according to instructions and always check if the part is located properly before pressing cycle start. Don't take your thumb off that feed hold button until the machine has started cutting without any problems. And seek out your HFO for advice on getting hands-on experience. Thanks for watching, and we'll see you in the next lesson.